个电脑和硬件都 OK 了，好，那我们就直接就开始。So it's the time for the opponent to choose the question.
So we wanted to oppose the problem 11 pumping stroke.
Problem 11.
and rotate it around its vertical axis. Water may flow out through the straw. Investigate how the geometry and other relevant parameters affect the pumping speed. And now mainly focus on how is the water pumped out by the straw, and how different parameters will affect the phenomenon. In the reporter's outline, first I will talk about the preliminary experiment. I will demonstrate the phenomenon and show the qualitative explanation. Then is the quantitative theory model. In our theory, we use Bernoulli's principle and the continuity of the liquid. And also, I will simply introduce the centrifugal force which may affect this phenomenon. And then in our experiment part, we have 6 different parameters, which are the half inlet distance, angle of the straw radius, angular velocity, and the length of the straw, and also the immersion depth. And finally, I will conclude the above. For the preliminary experiment, for our experimental setup and equipment, we use aluminum extrusion to support the mortar and to make sure it's stable on our setup. And also we use the plastic to make a water collector. And the water pumped by the straw will fill into this collector and then go down through the pipe which was here and then go out to the break peak. And then this pipe was for the water, for the extra water to flow out of it. And we'll also have the pipe here to put in the water to make sure that the water is on the same surface. And we use 3D print to print the straw to make sure it's controllable and to make sure it's the quality of the straw. For the phenomenon demonstration. In this video, we can see that the water fill the straw from the bottom to the top. And how the water shows in the straw is like, it will, initially it will start to fill the bottom of the straw and then go up through the wall of the straw and then fill the straw and pump out by the straw. For the qualitative theory model, when you give the straw an angular velocity, and you will produce a centrifugal force which may make the water pump out by the straw. And to explain how the centrifugal force works in this phenomenon, when the component of the centrifugal force is larger than the component of the gravity, and the water may pump out by the straw. For the quantitative theory model, we use the Bernoulli's principle, and which was original will be like not this, but we consider the energy loss, so we pass this up here. And according to the continuity of the liquid, we could have this equation. For the experiment part, the first parameter is the half inlet distance, and we will measure the pumping rate. For the half inlet distance, when the distance increases, which means the velocity V2 will increase and the pumping rate will increase. You can also see that in the theory, which was this R will increase and then make all of the velocity increase. And to this is our theory line. It may be some deviation because of the energy loss. If we didn't really see it. And for the parameter 2 is the theta. And when the theta increases, the rotating radius will decrease. And the water needs to overcome more sliding force, so the pumping rate will decrease. And in this chart, you can also see there is the deviations between the theory and the experiment. It might be because of the perturbation of the vortex that pumping the straw, when the straw rotates and it produces. And in the equation, you can see that when the theta increase, the V2 will decrease. The third parameter is the radius of the straw. To see how the radius of the straw affects the phenomenon, we can use this formula, which was in this you can see that when the radius of the straw increases, the centrifugal force will become larger. So the pumping rate will also increase. And you can see that this is more larger than the 0.3 centimeter long. So in the theory, you can also see that when the R increase, which was a big R increase, and the velocity will increase, so that also make the pumping rate increase. For the angular velocity, in the chart, you can see that when the angular velocity increases, the pumping rate will increase due to the higher frequency of rotation. And also, this part of some deviation is also caused by the vortex or the perturbation that which was affect the water's velocity. And in this part, you can see that when the omega, which means the angular velocity increase, so the pumping velocity will increase and the pumping rate will increase. And the increments of the omega may produce vortex to cause the deviations. And when the length, we found that the boundary condition is when the length is 9 centimeters long. The boundary condition of omega is 180 RPM. For the length of the straw, when the length of the straw increases, the rotating radius will increase, which will affect the centrifugal force, and the V2 will increase, and they also make the pumping rate increase. As you can see in the theory, you can see that when L increase, the velocity is supposed to be decreased. And we think that L won't have the boundary limits because of when the length of the straw increase, the rotating radius will also increase, so that they will produce more centrifugal force, so that the L won't have the boundary limit. And for the immersion depth, when the immersion depth increases, the velocity of the water will increase, so they will make the pumping rate increase. Due to the chart that when the immersion depth increase, it may also produce more vortex or the perturbation of the water, so they will make the pumping rate have some deviations to the theory. And for the conclusion, how is the water pumped out by the straw? When we give the straw an angular velocity, and it will start to produce some centrifugal force, which was the direction was from the inner part to the outer part. So the water may pump through the straw from the bottom to the top, and then pump out from the top of the straw. So when the component of centrifugal force is larger than the component of gravitational force, the water will pump out by the straw due to the centrifugal force. And how different parameters will affect the phenomenon. There are some parameters that will give the positive effect, which are the half-inlet distance. Because of the half-inlet distance increase, the rotating radius will increase. Also make the centrifugal force increase, so they will make the pumping speed increase. And the length of the straw will increase because when the length of the straw increase, the rotating radius will increase, so they will also give positive effect on this phenomenon. And when the angular velocity increase, the frequency of rotating will increase, so the water pump out more, so it will give positive effect. And the immersion depth, when the immersion depth is deeper, so they will make the velocity of the water is larger, so they will make the phenomenon become more significant. And the straw radius will also affect because of the cross-sectional area which makes the water pass more. And the parameters that will give the negative effect is the data. Because if the data increases, the rotating radius may decrease. So they will make the water needs to overcome more sliding force. So that will make some negative effect to this phenomenon. Thanks for listening.
Okay, so first we need to turn to the page of the problem statement. Yes, problem statement. So we first be definite about the pumping speed in the problem statement, which is described on your experiment result procedure. So what's the definition of pumping speed?
Pumping speed means the water comes out in per time.
So you mean is the water that immersed, the velocity of water immersed out?
Yes.
Okay, understand. And secondly, can you turn the page of your experiment setup? Next page. So in this video, do the water has fulfilled all the straw, or it just partly filled the straw by the procedure as in pumping out?
From the beginning of the video, because of it's just put into water, so it may not fill all of straw. But when we put it in the water a time after, it will fill all of the straw.
So you mean that during the procedure of pumping speed, that as it's spinning, the rotation, the straw will be fully filled with water?
Yes, due to the continuity of difference.
Okay, understand. Then can you turn to the page? Okay, so next question is, as you have concern to use a motor to control the velocity, so how are there several velocity? How many velocity have you controlled? Just do you control the velocity of the angular velocity of the motor?
Yes.
So can you tell me some certain angular velocity that you have concern?
In our parameters, which are from 300 to 500.
Okay, understand. And next is, what's the definition of half inlet distance?
Since this is the inlet part, right?
Okay.
This is inlet part. So the distance from the middle part to the.
Okay, understand. And last question is about the, okay.
Thank you.
good morning, listening fellows and honorable judges. I'm the opponent from Team Relativity, and today I'm going to oppose problem number 11, pumping straw. And here's the problem statement. A single water pump can be made using a straw into a triangle and cut up into vertices. When such a triangle is partly immersed in water with one of the vertices rotated around the vertical axis, the water may flow through the straw. But the problem statement is investigate how the geometry and other parameters affect the pumping speed. But from the reporter's report, I didn't consider about the geometry that they have concerned. So this may be the first discussion we have to discuss. And secondly, for the theory of condition, the reporter has used the Bernoulli principle and the continuity of a liquid to discuss about how the water has fulfilled through the pipe of the pumping straw, and also the angular velocity to discuss about the centrifugal force, which caused the water to pump out through the pumping straw. And as for the experiment, the setup has a variable speed sensor, a water collector, and pipes. And as for the parameter, they can control the parameters of length of the straw, immersion step, half inlet distance, angular velocity, and straw radius. So as I previously mentioned, they didn't consider about the geometry of the pumping straw, which may be one main focus for the problem statement. And as for the result, we consider the positive is the length of the straw, immersion depth, half inlet distance, angular velocity, and straw radius, which cause the straw pumping speed to be increased. But as the negative part is because of the angular of the straw. And as for the reporter, they consider that he has a lot of experiments to prove their assumption by their modeling is quite well to explain this phenomenon, and also to control the rotation speed in a good setup, and also they have a clear observation video. But as for the suggestion, we consider that the analysis method in the result may be one important effect because we still didn't understand how they to analyze the angular velocity of the pumping straw setup. And also they have no max theory and model on discussing about the pumping speed. That they'll build some clarification at this part. And so next will be the discussion. So firstly, we have to discuss about how will the capillary affect this problem statement, because normally that's going to be concerned that. And secondly, is that the following understanding about the Bernoulli principle and the condition, because that some conditions it might not fit in the condition. So we have some variation about this part. And certainly, the conceptual clarification of pumping speed, because normally the definition of pumping speed is not that we have discussed from the opponent's report. It's about how as the water pump out, like amount of water pump out through the time has passed. And fourthly is discussed about the viscosity and the most important parameters which affect this phenomenon. And as for the experiment, we consider that the most important condition and second is if the experiment and theory has some matched conditions, and what is the duration of collision and something. And yes, it's about the discussion.
So please start the discussion.
Okay. So firstly, can you turn to the page of your setup? Yes. So normally how you have used a motor to control your angular velocity, right?
Yes.
So how do you measure the angular velocity of how the water is drawn?
Since the motor has a screen aside this, so the screen shows the real speed of the rotation. So I will know about how speed the motor turns.
Okay, understand. And so can we move to the whiteboard?
Yes.
So firstly, I have to ask about that. Do you concern the radius of the straw will affect this phenomenon?
Yes.
So do you concern it as a capillary tube in this condition?
Not really, but we think in our theory we think the Bernoulli principle, which was caused from the pressure, will affect this one.
Okay, understand. Because okay. And so the next question is, do you consider the viscosity of the water will affect this phenomenon clearly?
We didn't do experiments, but I think if the viscosity is more larger and which was the energy loss will be more larger, so that they will affect the phenomenon.
Okay, so do you think that in this condition, the water's viscosity will be large or small? Do you think?
I think in this condition it will affect, but won't affect like some other parameters affect like a lot.
Okay, I agree, because normally the viscosity of water is very small, so it can be ignored to this condition. Okay, so the next question is that what's the definition of pumping speed in your experiment? That you briefly mentioned is about how the water is shooting out, right?
Not really, because I say the water pump out per time. So which was the ml per second? Right?
Okay, understand. So we concerned that your clarification of pumping speed is about the amount, amount of water that pumping out through time, right?
Yes.
Okay. So the next question is, do you have a critical angular velocity of how the water pumped out?
Critical angular velocity, if the angular velocity increase, then won't have some boundary condition, but when the angular velocity is too lower, so which was in this part, we say that when the throw length is 9 centimeters and the boundary condition of omega is 100 rpm. So that's the lowest angular velocity.
So you mean that in this such critical angular velocity, it has the most effective condition?
Can you repeat again?
Like you mean that you concern this experiment as a parameter, right?
Yes.
So you consider that at this condition, it will be the most effective concern in the positive angular velocity.
Yes.
Okay, understand. So the next question is that as you previously mentioned of the parameters of the pumping straw, you have concerned 5 different parameters, but in 6 different parameters. So do you have any parameters which have concerned the geometry of the pumping straw?
I think the data could be some part of the geometry. Since if the angle was 90 degrees, it may not pump out water, right?
Yes. Okay, I'm concerned this is a group. Okay, so then can you turn to the page which has your model part? Yes.
Is this part?
Yes. So at this part, how can you tell me how you concern this part? Is the continuity of liquids condition you fit in the Bernoulli's principle?
Not really, because of the water flow may have some energy loss when it needs to flow up. So we consider this to measure the energy loss.
Okay, understand. Then can you turn to the page that you have discussed about the angular velocity? Yes. This page, yes. So do you concern that this theory line is the experiment line is linear to fit in your experiment data?
Yes.
Is it linear?
I think yes.
Okay. So and the other question I will be concerned is about that. Do you concern that the Bernoulli principle in a large air pressure condition will fit in this experiment? Due to which because you concern the Bernoulli principle in this condition, right?
Yes.
So normally the Bernoulli principle condition you fit it will be in such a condition that means there will be a large air pressure.
Yes.
So which condition can you show that the large air pressure will be in this part of the experiment that you can show?
That may not be the air pressure, but the pressure of the water. So when this part of the pressure is higher, so that it will make the water flow up through the straw and then flow up.
So normally you concern that the Bernoulli principle is the main factor which causes the water to pump out.
We use Bernoulli principle to explain this phenomenon.
Okay. So can you turn to the next page? Page 12. So how do you concern that how it was distance to fit in to concern it as the manipulate variable to concern the geometry? Is it concerned to the geometry parameters or?
It might be some part of the geometry, but not really most part of the geometry.
Okay, understand. And for the next part, I will want to be asked about the angular velocity that we discussed before. Okay, so firstly, that you measure the angular velocity by?
By the motor, itself has a meter to measure how the pump's real velocity.
Okay, so do you consider that the angular velocity is the most important parameters?
I think all the parameters are important because they will all affect the phenomenon.
Okay, so is it important? Is it one part that is discussed about the geometry, or is another parameter to be discussed?
This is another parameter to be.
So which is the most important? Is the geometry or the angular velocity?
I think the geometry will affect the structure of the stroke, so that will make so they will also affect how the angular velocity acts on the pumping stroke.
Okay, so can you turn to the page of your conclusion? Discussion of your conclusion. Yes, so at this part you have described it's about the centrifugal force.
Yes.
So can you describe at which part it's because of the centrifugal force was caused this condition, and at which part it's because of the Bernoulli's principle?
Because of the centrifugal force condition will not perfectly fit the experiment. So we choose to use the Bernoulli's principle, which will fit the board, and it was a correct condition.
So from your schematic, is it a simulation or is it just a schematic?
It's a simulation.
So you mean it's a true condition you have simulated, right?
Because this part's pressure was more higher, so there.
But normally, if you use Bernoulli principle to discuss about this geometry, it will be partly the tube will be fulfilled with water. But
Yes.
from your simulation, it's just partly fulfilled. But
I just want to tell you that the water may flow up through the wall. So
you mean that it's truly the real condition that you have used the simulation?
no. We use the simulation for the fulfill of the stroke.
Okay. So can you turn to the next page? Yes. So can you tell me that what's the meaning of this graph that you have discussed?
So to show the spirit of the pumping rate, right? And as well as to see this narrow, it will be the positive effect on the phenomenon.
So do you concern that the inlet distance will be also affected by the angular theta of the pumping stroke?
I don't think the angular velocity will affect the theta because of
No, I mean that because normally you mean the half-let inlet distance is the distance that of the pumping stroke at this part to connected with the vertical axis.
yes.
So how do you control that in every condition if you control the same half, if you variable this different half inlet distance, the angular of the pumping stroke will be the same?
Because we use 3D printer to print the stroke, so the stroke structure of this part, which was without the plastic stroke. This theta is the control variable of the 3D printer stroke.
So you mean that the definition of your theta means is how the angle of the straw this part has control with this.
Yes. And so the stroke will put it right here so that the theta will be the same. So it won't affect the exact distance.
Then, but normally from the geometry of the pumping stroke, I think it will be like this, right?
Yes.
But at this part,
Time is up.
okay.
Thank you.
So the opponent please summarize the discussion.
Okay, so firstly, we have discussed about the definition of the pumping speed. And firstly, we think that the definition of definition of pumping speed, that we have some clarification of what's the really true definition of the pumping speed. Because we first got to clarify about what the definition, and secondly, is ask the points that he used the Bernoulli principle and how the viscosity effect and the definition of the pumping speed, and which have clarification of the discussion that we previously mentioned. And so then we have discussed about how the conditions of critical angular velocity in this condition, and here found out that it's because of about the lowest condition which fit in this experiment. And for next we have discussed about the geometry, because first we have considered it because that the parameter they considered is not because of geometry, but then we have discussed. And third is that is the theory line linear, and what's the most important parameters.
So please start.
I want to ask both of you first ask the opponent that what do you think is the main factor according to the report? What is the main affecting factor? We have Bernoulli's erosion and centrifugal force and continuity of the liquid. Which do
I'm
you
still
think?
concerned is because of the centrifugal force, because that the rotation speed of how the motor spin is very fast.
Okay. And how about further?
I think the way to explain the phenomenon is a Bernoulli principle, but we will concern the centrifugal force as the most effective part, since the component of the centrifugal force will overcome the component of the gravity, so it will make the water pump of the liquid.
Okay, so next question for both of you. Do you think the viscosity will affect the experiment?
Oh, I consider in this condition it will affect because the viscosity of water is very small, so it can be more.
Do you think that
Since we just mentioned in the discussion, I agree with the opponent.
So do you think that when the parameter of L is longer, the viscosity will be more?
Why will it affect the viscosity? I don't really understand what you're saying.
Okay, so you think that the L won't affect the viscosity?
Because of the viscosity of the water is controlled by not affected by the depth.
Okay. And do you think that the parameter of the L will affect the viscosity?
Not really, because it's not the quantity of water.
Okay. And I want to ask the opponent that what do you think is the most important fraction to this experiment?
You mean the parameters or?
The parameters.
Simply from the conclusion, I consider it because of the angular, because normally that you can see it's the only effect of the angle.
Okay. Thank you.
The reviewer, please take the floor.
here's a summary of the recorder. First is their there, and they're set up with motor, water collector, pipe, and straw, and their parameters. And for tapping index distance, and then of the straw, and straw's radius, and the angular velocity, and the immersion depth will be positively correlated with the pumping speed, and the theta will be negatively correlated to the pumping speed. And here are some overview of the project. Their advantage are the details of the theoretical results and graphs. And there are some suggestions that their layout definition and forces not measured or calculated which may affect the experiment. And the overview for the opponent first is the advantage. They have counted dents and count and mentioned variables that important and take into consideration. And some suggestions that also not mentioned the initial value. And versus their discussion is that will water fill up the whole straw or just a part of the straw? And further answer that after a short time, the straw will be filled up with water. And we think that is because of the velocity. When the velocity is too low, the straw won't be filled up with water. And the second discussion is how to measure the angular velocity. And further answer that by the screen under equipment. And the third discussion is the definition of the pumping speed. The further answer that they measure the amount of the water coming up per time. And we think that maybe they can try to measure it by projectile motion and horizontal axis and the vertical axis. And their fourth discussion is that they will consider the viscosity and the reporter answer that will affect, but not much, so they don't think that it won't matter. And we agree to our opponent. And for discussion 5, they ask the geometry of the straw. And they mention the whole geometry of the straw. And they answer that it's a part of that, and we agree to the reporter. And for discussion 6, they ask what is the most important factor. And the reporter answered the whole factor that is 6 variables in their experiment. And we think that maybe the angular velocity is the most important. And we ask that can you ignore the viscosity? And the reporter thinks, and the reporter and our partner thinks that they can neglect the viscosity. And we agree that L won't affect the viscosity, won't affect the velocity. But the theory of the reporter is considered L in the definition of the viscosity. Thank you.
This is our concluding remark. The first is water will fully fill the straw when the conditions are stable. Then we can use the theory of continuity of liquid, since the water flow into the straw and water flow out of the straw are the same. And the angular velocity of the setup is controlled by using a motor. The motor will have a screen to show how the real velocity it has. And the definition of pumping speed is the amount of the water pumped out per time. And the centrifugal force is the most important factor of this phenomenon. But the geometry of the pumping straw are also variables factor to this phenomenon. Since the centrifugal force will affect is the force that makes the water flow out of the straw. And the geometry will affect how this force acts on this phenomenon. And we simulated the phenomenon using the fully filled straw condition. We just want to show how water stops come from the walls of the water, so that the picture in our TPT was not fully filled. And the inlet distance won't affect the setup, so we only varied one variable during the experiment. And the viscosity of the water is too small to be considered. But we have considered it in our theory. And the viscosity of the water stayed the same in our experiment because they are water, not other liquids, so the viscosity won't change. Thank you.
So it's the time for the
the pumping speed, angular velocity is 0, do you have a pumping speed?
I think the water won't pump out by the straw.
Yes, but do you, from the equation, does it tell that?
It won't. I think that
From your equation, do you think if the omega is 0, then the pumping speed is 0?
I think it will.
Well, and you from your experimental data, do you think you have if the x-axis goes through 0, your experimental data will go to 0?
Yes.
You think so?
Oh no. Sorry.
So what's the opinion? Why is her experiment, the pumping speed goes to 0, but you still have some finite?
So this-
sorry, the angular velocity goes 0.
So this is why that from the discussion that I want to find this part, because that from this the equation it seems that it's not linear to the theory fitting at what they are written. And also I'm concerned that at this in this zero conditions the velocity won't be 0. So I think it's quite weird that so we have this discussion because normally in other parameters in this equation didn't be considered in this.
How about the relation?
I agree with the opponent that some parameters that are originally concerned.
Sorry. Can I answer again? So the dissipation will larger than the from the equation, so there will make some deviation.
Just two simple yes or no questions to the reporter. First, do you consider your water pump simple? Yes or no? Do you consider your water pump simple?
Yes.
And could it be done just by one single straw?
I think it.
Yes or no?
Yes.
So then I have a question for the opponent. So you asked which parameter is the most important. What do you expect?
Firstly, I previously explained it's because of the angular, but I asked my considerations that I now consider it's because of the angular velocity, because I think that the centrifugal force will be the main effect to this phenomenon rather than a Bernoulli's principle.
So is there any further question? No. Then let's make the score. Mark the score. The score for the reporter 7,7,7,7,8. The score for the opponent 8, 9, 7, 8, 9. The score for the reviewer 6, 6, 6, 7, 7. Okay, so let's have a short break. Yeah, so I would like to suggest that we only take a break